Hello viewers, in today's class, let me teach the methodology to calculate reaction and bending moment in case of two hinged arches. Two hinged arches inside, arches will have two supports and supports will be hinged. This is more practical and this is construction may be easy but the analysis is very difficult. Let us see the different concept behind the analysis of this arch. Two hinged arches will be like shown in figure. It will have two supports. The supports will be hinged, and they are very more practical. In regular practice, we will be having two hinged arches only. And in these two hinged arches, we have got four unknowns. One is first unknown is the vertical reaction, two vertical reaction, two horizontal reaction. There will be four unknowns. The number of equilibrium equations available are 3. So one force becomes redundant. The horizontal thrust on one end is taken as redundant force in case of two hinged arches analysis. So since the conditions of equilibrium are insufficient to find the horizontal thrust of the arch, so the structure becomes statically indeterminate. As I told you earlier, the horizontal thrust is considered here as the redundant force. So in order to solve this kind of problem, strain energy concepts are used here to find out the unknown factor, unknown redundant force, that is horizontal thrust. According to the Castiglione's second theorem, displacement due to a force is given by partial derivative with respect to the force creating the displacement. Since the force here is the horizontal thrust, so the force, the unknown force, the redundant force may be here as the important thing to find out to proceed the problem. So the horizontal displacement may be given as dou u by dou h, where u is the strain energy, h is the horizontal force. The partial derivative of strain energy with respect to the horizontal force is given as the horizontal displacement. At the same time, the supports are hinged, so the horizontal displacement of the support is 0. So naturally, dou u by dou h will become 0. In order to find out the horizontal thrust, let us name the different components of the arch. The arch supports are named as A and B. Vertical reaction at A is VA. Horizontal reaction at A is HA. At the same time, vertical reaction at B is VB. Horizontal reaction at B is HB. Let us take section XX such that it is X distance from support A, and the intersection point on the arch is Y distance from this line joining the supports A and B. We know the strain energy is equal to integral A to B mx squared by 2EI ds, and let us consider that it is equation 1. Here the integration is between the support A and B. Integration has to be carried out along the arch axis. Mx is the moment at any section x, and the integral operator is ds, that in sense the integration has to be operated along the axis. The mx may be given as mu minus hy, that is, mu is the moment due to the vertical reaction, that may be equal to Va into x, and moment due to horizontal reaction is hy. So substituting here in the equation 1, we will be getting new form of equation, that is integral A to B mu minus hy square by 2EI ds, that is equation 2. We know the supports are hinged, so the horizontal displacement is 0, and differentiating u with respect to h will be equal to 0. From the earlier concept, we understood that dou u by dou h is equal to 0. So let us rewrite the equation 2. Equation u stated strain energy is equal to integral between A to B and mu minus hy whole square by 2EI ds, that is equation 2 that we have seen earlier. Now let us differentiate this in the inner part of integration. The equation will become like this: dou u by dou h is equal to integral A to B minus hy minus y divided by EI. Once we integrate, we will be getting minus hy, mu minus hy into minus 2y divided by 2EI. 2 will get cancelled. As a result, we will be getting this form: minus mu minus hy into minus y by EI is equal into ds is equal to 0. So equating this value is equal to 0, we will be getting this form: integral A to B mu minus hy into minus y by EA ds is equal to 0. So splitting this, we'll be having integral a to b mu I by ei ds plus integral a to b hy square by ei ds that is equal to 0. Taking h out and the less part of the equation on that side, you'll be getting the equation as integral a to b mu I by ds divided by integral a to b y square ds. This is equation 3. Based on this equation, we can find out the value of horizontal thrust. Let us now reduce the integral operator ds into dx form. For this, let us consider the arch axis. Let us consider small element dx and dy like this. Small element along the arch axis ds that may be split into horizontal component and vertical component. Vertical and horizontal direction is dx. Vertical direction is dy. The angle between making the arch axis with the horizontal is equal to theta. So cos theta will be equal to dx by ds, and dx alone will be dx divided by cos theta. 1 by cos theta is secant theta. So dx will have the form dx secant theta. Let us substitute the value of dx in the equation 3. So substituting here, the equation 3 is shown here. There is in the h is equal to integral a to b mu y ds divided by integral a to b y square ds. There is the equation 3. Let us substitute the value of ds with dx secant theta in this equation. As a result, we will be getting integral a to b mu y dx secant theta divided by integral a to b y square dx secant theta. Secant theta will get cancelled, and h will have a reduced form like this: integral a to b mu y dx divided by integral a to b y square dx. With this equation, the form of in terms of y and z, so it is very easy to integrate and find out the value of horizontal thrust. So this equation gives you the expression to find out the value of horizontal thrust. Let us see some of the standard cases. In all standard cases, the vertical reaction VA and VB may be determined by taking moment about the other support. That is what we practice in simply supported beam also. The same methodology may be also practiced here. For in the case of arches, let us take the standard case. Two standard cases. Number one, arch 2-inch arch subjected to UDL. So 2-inch arch subjected to UDL will be of this form. So 2-inch arches will subjected to UDL at the top throughout the span. We can find out the value of reaction as total load divided by 2. Total load is WL. And divided by 2 will be equal to VA and VB. The horizontal thrust may be calculated from the standard formula WL square by 8, or this is for standard case of arch 2-inch arch subjected to UDL. Suppose if it is point load, let us consider the point load is being subjected at the center of midspan of the arch. Here also the total load divided by 2 will be equal to W by 2, and that will be equal to VA and VB. And substituting the value of taking any section and finding out moment at that section will be Wx by 2, and using the equation of parabola y is equal to 4 RA by L square into x into L minus x, and substituting these values in earlier equation that we have got for horizontal thrust, we can find out the value of h. So from the standard equation and using the standard equation for horizontal, derived equation for horizontal thrust, we can find out the value of h. To understand the concept of a procedure to find out the reaction bending moment, let me explain with an example. The example says like this: a parabolic arch hinged at the end, both ends, has span of 60 meters and a rise of 20 meters. The concentrated load of 8 kN acts at 15 meters from the left hinge. The second moment of area varies as the secant of the inclination of the arch axis. We have to calculate the horizontal thrust and the reactions at the hinge. We have to also calculate the net bending moment at the section. It is given that the second moment of area varies as the secant of the inclination of the arch axis. That in sense, that shows the bending moment has been taken along the arch axis, and we can use the equation arrived for horizontal thrust, that is equal to integral a to b mu y dx divided by integral a to b y square dx. To understand the problem, to solve the problem, let us write the given data first. First data is the span that is equal to 60 meter. Second one is rise that is equal to 20 meter. Third one, load 8 kilonewton at 15 meter from A. And fourth is the given condition, second moment of area varies as the secant of the inclination of the arch axis. That has to be also included in the data. That shows we have understood the problem, that is moment has been taken along the arch axis. And we have to find out the following things. Number one, horizontal thrust. And number two, the reaction at the hinge RE and RB. Number three, net bending moment at section MX. To solve the problem, let me take to the real classroom, let me work out the problem on the board so that the understanding may be very clear. Based on the given data, let us proceed the problem. The given data is like this. This two hinged arch has got a span of 60 meter. The horizontal distance between the support is 60 meter. This is support A and support B. The load acts at this point. Magnitude of the load is 8 kilonewton and it acts at a distance of 15 meter from left support. We have to find number one, the vertical reaction, horizontal thrust. Number two, the resultant reactions at A and B. At the same time, the horizontal thrust also at A and B. Number three, moment at the load point. Moment at the load point. Moment at the section, we can say. So the first step to find out the vertical reaction. Finding out the vertical reaction is the first step. To find out the vertical reaction, let us take moment of all forces about A. Moment of all forces about A. So take moment about A. Let's take moment of all forces about A. The first force is the vertical reaction at B and horizontal reaction at B. Other forces are the vertical reaction at A and horizontal reaction at A and the applied downward load. Out of all these five forces, three forces, 1, 2, 3 are passing through this point. So we need not include those points to take the moment. The first force which is not passing through this A is VB. VB into 60. It is making an anti-clockwise rotation, so this is negative. The second force is the downward force. This is 8 kilonewton. It acts as 15 meters from this point and it is making clockwise rotation, so it is positive. Sum of the moment is equal to 0. So this is minus 60 VB plus 120 is equal to 0. Minus 60 VB is equal to minus 120 and VB is equal to 2 kilonewton. The total load is 8 kilonewton. We know VA plus VB is equal to total load. VA we don't know. VB is found to be 2 kilonewton. Total load is 8 kilonewton. So VA will be 6 kilonewton. The second step is to find out the horizontal thrust H. Horizontal thrust. Horizontal thrust H is the second step. To find out the horizontal thrust, let us again go to the load, the real free body diagram. Support A, apply load points. This is acting at 15 meter from left support. The whole span is 60 meter and this is 45 meter. Right, this is 45 meter. From the earlier calculation, from the earlier derivation, we found that the horizontal thrust is given by integral A to B mu y dx divided by integral A to B y square dx. Relate to b. This is from the earlier derivation. Here we have got one load point. So this numerator we have got mu y. Mu is the moment due to the applied forces, moment due to the vertical forces. So since we have got one point load, we have to split in this two. First one 0 to 15 and second one 15 to 60. And this is another 45 meters. So we can split this numerator into two. So the new equation will be integral 0 to 15, first part, that is mu 1 y dx, plus integral 15 to 60 mu 2 y dx, and in the denominator 0 to 60 integral, it has to be integrated across the beam from A to B, so 0 to 60 y square dx. So we have got two numerator component and one denominator component. So it can be written as numerator 1 plus numerator 2 and divided by the denominator. We have to calculate the numerator and denominator values separately, and we can substitute here and we can find out the value of horizontal thrust. Let us first calculate the denominator part. Denominator part is integral a to b y square dx, where y is the equation of the parabola. The value of y is 4r L square into x into L minus x. This equation of a parabola. We have to substitute this value here. So substituting this value, we will get denominator a to b 4r L square x into L minus x dx. Now this is a to b in front, this is the span of the arch, so this is 0 to 60. Now let us also substitute the remaining values. 4, rise of the arch is given to be 12 meters and span of the arch is 60 square, x we don't know, and span of the arch again is 60 minus x dx. Now this is integral 0 to 60. Let us simplify this component. Here it is y square, so it is to be squared out. It is to be squared out. So here it is 0 to 60, 412 by 60 square to the whole square into taking this component x into 60 minus x whole square dx. So here this is 0 to 60. Solving this, we will be getting, here it is 48 square divided by 3600 whole square. So we can put it as like this, whole square into x into 60 minus x whole square dx. This is equal to integral 0 to 60 2304 48 square divided by, and squaring out 3600, it will be 1.29 into 10 power 7, and this will be x into 60 minus x whole square dx, and this will be reduced to 0 to 60 1 by 5625. Dividing this value by this value, you will be getting 5625, and this is x into 60 minus x whole square dx. In this equation, we can take this component out of the integration, 1 by 5625 0 to 60. Here multiply x inside the bracket, so it may be 60x minus x square whole square dx, and this will be 5625 integral 0 to 60. 60, this is a minus b whole square, so this is 60 square plus x square whole square minus 2 into 60x 60a into b. So this will be the a minus b whole square formula, and again simplifying this, we'll be getting 562502 60. This is 60x square plus x to the power 4 minus 60 120x, and again x square, this will be 120x cube dx. 120x cube dx. Again 60 square in sense, 60x square plus 60 square, this will be 3600. 3600 x square to the power 4 and minus 120x cube. This is again rewriting, integrating. Now performing the integration, 3600. Once you integrate x square, this will be x cube by 3 plus x to the power 5 by 5 minus 120 x to the power 4 by 4. And it is integrated between the limit 0 to 60. Now let us substitute the limit value in the integrated equation. So this is 3600 x cube by 3 we have got. This is also x cube by 5. That process the equation we have got. 120 x cube x to the power 4 by 4. It is to be limit 0 to 60, and cancelling out, this will be, you can get 1200, and here again this will be equal to 4 times, so this will be 30. Substituting on further simplification, we will be getting 120 x cube plus x 5 minus 30 x to the power 4, and within the limit 0 to 50. Substituting the values of the limit, 1200, limit value 60 cube minus 0 cube plus, here this is 60 to the power 5 minus 0 to the power 5 by 5 minus 30 into 60 to the power 4 minus 0 to the power 4. So this is reduced to the 4608. This is the value of the denominator. Numerator 1 is integral 0 to 15 mu 1y dx. That is, so this is what the arch, the load is being applied here, 8 kilonewton, section 1 and section 2. We have to take load from this end, and we have to take the load at this point. So the value of mu1 will be VA into this x distance. X distance between this load point is 15 meters. So value of VA is found to be 6 kilonewton x. Let us have this as a substitute it as x, because it will be varying from 0 to 15. So lower limit is 0, upper limit is 15. So let us have it as x. So substituting here, numerator 1 will be integral 0 to 15. Value of mu is 6x and y dx. Y is nothing but, this is the equation of parabola. That we know very well. Equation of parabola. Substituting that also here, 0 to 15, 6x. Equation of the parabola is 4r L square x into L minus x. This is the equation of the parabola dx. Substituting the values of the parabola configuration, 4 rise of the arch is 12 meter, span of the arch is 60 square, X we don't know, L is 60 and X we know. This is dx. It has to be integrated between the limit 0 to 15. We have 6x 4 into 12 divided by 60 square, x into 60 minus x dx. Multiplying all these components, we'll be having, that is 6 into 4 into 12, we'll be getting 288 by 60 square is 3600. Again, this is x square, 60 minus x, and this dx. Taking this component out and simplifying this and taking this component out, we'll be getting 1 by 12.5, that is 3600 divided by 288 will be 12.5. So 1 by 12.5, integral 0 to 15, x square 60 minus x dx. Again, multiplying this x square inside the bracket will be 60x square minus x cube dx. So this will be 1 by 12.5. Integrating this, we will be getting 60x cube by 3 minus x to the power 4 by 4. It has to be, the limits are 0 to 50. Now let us substitute the value of limit. This is 1 by 12.5. Here this is 60 into 15 cube minus 0 cube divided by 3 minus 60 to the power 4 minus 0 to the power 4 by 4. So this is 1 by 12.5. Cancelling this 3 with 60 will be getting 20, 15 cube on simplifying minus 15 by 4, 15 to the power 4 by 4. And this is found to be 4387.5. This is numerator 1. Now let us continue to determine new value of numerator 2. The equation for numerator 2 is, it is to be integrated between the limits 15 to 50 because it is mid-span. That is, after the lower point, it is 15 to 60. This is the span of the beam and mu2 y dx. Now, the value of mu2. So this is the arch, left side, support A, load is applied here, 8 kilonewton, at a distance 15 meters. So we have to find out the moment at this section, this after the load. So we have to calculate, include both the forces, this is VA, upward force, vertical reaction, and the downward load. We have to take moment of these two forces about this section. So first thing, let this distance be again x. So VA x into this distance, we have to calculate this distance. So this is x and this is 15. So this is 15 minus x minus 15. This is x minus 15. So, and about this point, this is making clockwise rotation. So this is positive, and second force 8 is making anti-clockwise rotation. So this is negative. 8 into x minus 15. This is what the value of moment about the section. So we have to substitute here for mu2 in this equation. On substitution, we will be having the numerator 2. Numerator 2 will be 15 integral 15 to 60. V is x minus 8 into x minus 15 into y dx. Let us first simplify this component VAX minus 8 into x minus 15. Let us simplify this component. And this will be, value of dA is 6x, 6 dx, and 8x minus 8 into minus 15, this is plus 120. And this again, this will be equal to 120 minus 2x. So instead of mu2, let us replace this value. So numerator 2 will become integral 15 to 60, 120 minus 2x, and value of y is equation of the parabola 4r by L square, x into L minus x dx. Now let us substitute the value of the parabola components. 120 minus 2x into 4 into rise of the parabola is 12 meter here, and this is L is 60 square, x we don't know, L is 60 minus x dx. So we have this equation, integral 0 to 50, and 120 minus 2x, and within the bracket 4 into 12 is 48, 60 square is 3600, into x minus 60 minus x, again dx. We have integral 15 to 60, 120 minus 2x into 48 by 3600, x into 60 minus x dx. Simplifying this, you'll be getting 1 by 75, and we can take the 75 out of the integration, and this will be 15 to integral 15 to 60, 120 2x, and this again multiplying this inside 60x minus x square and dx. We'll be getting the equation, and multiplying again these two components, we will be getting integral 15 to 60, multiplying this, we will be getting 7200 x minus, and this is minus 120 x square minus 120 x square plus 2x cube dx. 2x cube dx. On further simplification, we will be getting 7200 x minus 240 x square plus 2x cube dx. On performing the integration, we will be getting 7200 x square by 2 minus 240 x cube by 3 plus 2x to the power 4 by 4, limits are 15 to 60. And we can further simplify this equation. This will be 1 by 75 and 3600 x square minus 80x cube plus x to the power 4 by 2. The limits are 15 to 60. Now, substituting the values of the limits, we will be getting 3600, upper limit is 60 square minus 15 square minus 80 into upper limit is 60 cube minus 15 cube plus x to the power 4. For this, upper limit is 60 to the power 4 and 15 to the power 4 by 2. On simplifying this equation, we will be getting the value of numerator 2 as 21262.5. Going back to the earlier equation, horizontal thrust is numerator 1 plus numerator 2 divided by the denominator. We found the value of numerator 1 as 4387.5 and numerator 2 as 21262.5, and the value of denominator is 4608. On simplification, we get the value of horizontal thrust as 5.56 kilonewton. So by integration, we have found out the value of horizontal thrust as 5.56 kilonewton. Since there is no inclined force or any horizontal force, HA will be equal to HB, and value of H is taken as 5.56 kilonewton. Third step is to find out the values of reactions at A and B. The resultant reaction at A may be given by square root of VA squared by H square, that is equal to, we found the value of EA as 6 square plus 5.56 square, this is equal to 8.18 kilonewton. And the reaction at B may be given by square root of VB square plus H square. Substituting the value, VB is 2 square plus 5.56 square, and taking square root, we'll be getting 5.91 kilonewton. So this is what the value of reaction at A and reaction at B. Now we have to take the bending moment at the load point. So this is the load point, and this is 15 meter from A, and we have got vertical reaction and horizontal reaction. So the load at this point, the moment at this point will be equal to VA into X minus H into Y, because VA is making clockwise rotation, HA is making anti-clockwise rotation. VA is 6 and X distance is 15. Value of H is 5.56, and we don't know the value of Y. So value of Y may be found out from the equation of the parabola 4r L square x into L minus x. Here we have got 4 into rise of the arch is 12 meter, 60 square, x is 15, again 60, value of L is 15 minus 15. So the value of Y is found to be, 9. Substituting this 9 here, we'll be getting moment as VA X into actually now substitute all the values, 6, 15 minus 5.56 into 9. So this value of moment at this load point is found to be 39.87 kilonewton. So the value of the moment, the bending moment at the load point is 39.87 kilonewton. With this, we come to the end of the problem. Here we have found out the resultant reaction, horizontal thrust, and net moment at the load point.